The information contained in this presentation is intended for general informational purposes only. The presentation is not a substitute for a review of the applicable government regulations, codes, OSHA standards, or other regulations, and should not be construed as legal advice or opinion. Specific questions should be referred to the proper regulatory authorities, electrical engineer, licensed electrician, or attorney. We often see electrical ratings with similar but different voltages listed as 110 volts, 115 volts, 117 volts, 117.5 volts, 118 volts, 120 volts, and 125 volts. But which one is right? This product shows 110 volt, so that must be correct, right? But wait, this one shows 115 volts. That sounds right, doesn't it? Wait a minute, this one shows 120 volts. That sounds correct also, right? Confused at this point? But wait, that was just line to neutral voltage. What about line to line voltage? Here are some common ratings for the line to line voltage. 220 volts, 230 volts, 240 volts, and even 250 volts. See, it shows 220 volts for this item, so that must be it, right? 230, I've seen that one also. See, it shows that on this item, so that must be correct. Here is another. This label shows 240 volts. So which is it? In the United States, utility companies are required to provide a split-phase 240 volt feed to residential customers. This consists of two legs of 120 volts AC that are 180 degrees out of phase with one another. The AC voltage oscillates from plus 120 volts to minus 120 volts. With the two legs being out of phase, you can pick up 240 volts AC by using both legs rather than one leg and neutral. When you use both legs to feed a circuit like a range or water heater, you end up with twice the voltage, a line that oscillates from 240 volts plus to minus 240 volts. The neutral wire is not utilized in a 240 volt circuit as the current is fed by one leg and returned on the other leg. You'll often hear voltages referred to as 110, 115, or 120 volts. This can be confusing, but the bottom line is they are referring to the exact same thing. Here's why. In the US, the electric utilities are supposed to deliver power to residential customers at anywhere between 110 and 125 volts AC. The value 117 or 117.5 or 118 is often seen on products because that is the middle of the specified range. At one time, the US standard was 220 volt line to line or 110 line to neutral. But over the years, as power demands and generation capabilities have improved, the standard is now 240 volt line to line or 120 volt line to neutral. 110 volt is a legacy term left over from the past. 115 volt comes from the design side. Equipment is normally designed to run on 115 volt plus or minus 10%. 120 volt comes from the supply side. Under standard conditions, electrical utilities deliver electricity at 120 volts plus or minus 5%. Since there are resistive voltage drops in the house wiring, it's not unreasonable to find 120 volt has dropped to 110 volt or 240 volt has dropped to 220 by the time the power reaches the end, especially at the end of a circuit or extension cord run. It all begins here. 120 volt plus or minus 5% is the voltage on a single hot wire in a residence with respect to neutral or ground. With resistance in the wiring, this 120 volts will likely have dropped to 115 volts by the time it gets to the item you are powering. Some situations can create even more resistance. At the end of a long extension cord, you could even drop to 110 volts. This is why you'll see the different terms used. In fact, many appliances or devices will be rated 110 volt or 115 volt, which basically tells you they are tested to operate down to a lower voltage. This gives you assurance that at the end of a long circuit or extension cord, it will still operate fine. Sometimes a little education can make one more careless than before, as someone feels more comfortable in their knowledge. There is a cardinal firearm safety rule that says, treat every firearm as if it is loaded. That can be applied to working with electricity. Treat all electrical as if it is energized. By making this assumption, you will reduce your chances of an unwelcome surprise. If you make a mistake in plumbing, you might make someone unhappy. make a mistake in air conditioning, and someone might be uncomfortable. But a mistake with electricity, and you could injure or kill yourself or others. I realize that probably most of you watching this have already been shocked by electricity and obviously have lived to tell about it. Unfortunately, the more that occurs, the more it tends to lower our defenses. Please never take safety for granted and always treat electricity with the respect it deserves. Your life and the life of others may depend on it.